Here I'm going to go over converting position time graphs to a corresponding velocity time graph. And to a corresponding graph means that the velocity time graph is going to show different information for the exact same event that was given in the position time graph. So these correspond to each other. If I ran a motion sensor and I had it run a position time graph and a velocity time graph for the same event, these are the two graphs that I would get. First thing I want you to do is look at the position time graph and understand that the velocities are negative. So there's the velocity, there's two different constant velocities, one for the first 10 seconds, one for the second 10 seconds. And I want you to see that they're negative. So if you are plotting things up here where the velocity values are positive, you're doing it wrong. And maybe you'll do that out of carelessness or whatever, but hopefully you're looking at this and you're seeing I'm going to plot negative velocities. Hopefully you also see that from 20 to 30 seconds it's not moving. And hopefully you also see that for the first 10 seconds, it was going more slowly than it was for the second 10 seconds. Now we're going to calculate this, but again, just take a look at it and kind of think about what results or what you expect the results of your calculations to be so that you can make sure you are not making silly mistakes. So let's find the slope of this first little section of line. If you still want to find slope with the y2 minus y1 over x2 minus x1, go ahead. That's fine. But I'm not going to do that. I'm just going to look at this, and I'm going to look at the vertical axis change. And from this point to this point, it went down 50. And it went down 50 units of distance in 10 seconds. So I'm going to say, well, I know that slope is -5. And again, if you get -5 by doing more more involved calculation, I don't care, that's fine. So in the second part of the line, it goes from +50 to -100. Well, from +50 to -100, it went down 150. And that also took 10 seconds, and this would give me a slope of -15. I'm finding the slope of a position time graph, which is velocity. And I'm not going to show that calculation, but for the next 10 seconds, the velocity, the slope was 0. So I need to scale my axis on this velocity time graph to get me up to -15. So we'll call this -5, -10. I'll try to space them kind of evenly. -15, and I'm going to scale my time axis exactly the same way because this is the same event. It's the velocity time graph for the exact same event as the position time graph. So I'm going to scale it the same way, 10, 20, and 30. And now I'm just going to convert this. Now I'm just going to say, well, for the first 10 seconds, it had a constant velocity of -5. Constant velocity of -5 is a straight line here at -5. And I have that go up to the 10 because that lasted for the first 10 seconds. For the next 10 seconds, it was at -15. So I'm going to go down here to -15 and show it was at that constant velocity for the next 10 seconds. And then for the last 10 seconds, it was at 0. So I'm going to go back up here. There's only one place where velocity is 0. That's the horizontal axis in a velocity time graph. And that shows that for the rest, or for the last 10 seconds, 20 to 30 seconds, it had no velocity. It was at rest. Here's number 2. Again, the first thing I'm going to do is look at it and kind of get a picture in my mind of what the velocity time graph should look like. I don't just want you plugging numbers in and churning out values and not thinking about what they mean and making stupid mistakes and not catching them. So I can see that for the first 5 seconds, there's a steeper slope than there is for the next 5 seconds. So I would expect the velocity for the first 5 seconds to be greater than for the next 10 seconds. I can also see that even though all these points are plotted below the horizontal axis, even though every single position value is negative, the velocity is positive. Where this object is has nothing to do with its velocity. All of this is going on in at whatever positions we've denoted negative, but the entire time the slope is positive, the velocity is positive, the object is moving in some direction that we decided was positive. So I expect both of these lines to be above the horizontal axis, and I expect the first 5 seconds to be higher up on the velocity time graph than the next 10 seconds because it's going faster. And speed in a velocity time graph is related to how far the object is from 0. So let's just find these values. This goes from -50 to -25 in 5 seconds. So it goes up 25 in 5 seconds, which gives me a slope of +5. This also goes up 25. It goes from -25 to 0, so it also goes up 25, but this takes 10 seconds. It takes from 5 to 15 seconds, which is 10 seconds, So we get a positive slope of 2.5. I'm not graphing any negative numbers here on my velocity time graph. There are no negative velocities. Here's 2.5. Here's 5. And I'm going to scale my time axis in the same way because these graphs both represent the exact same event. So here's 5, 10, and 15. For the first 5 seconds, it was at positive 5. And for the next 10 seconds, it was a positive 2.5. And this represents, it's a horizontal line, or it's supposed to be a horizontal line, and it represents a constant velocity. So that is what that graph should look like. And it is what I thought it should look like. Both lines are above the horizontal axis, showing a positive velocity, which they should have because there's a positive slope. And the second 10 seconds, the slope is not as steep, and in fact, it has a smaller velocity here. I calculated a smaller velocity, so it's all good. Here's number 3. Hopefully you can see the first 5 seconds. What's the velocity? Well, its position isn't changing. It's just staying there in one spot. Its velocity is 0. For the next 5 seconds, from 5 to 10 seconds, it goes from positive 30 to negative 15. We can see this line has a negative slope. It has a negative displacement. It has a negative velocity. How far does it move along this vertical axis? It moves down 45. And again, that's between 5 and 10 seconds. So that takes, 5 seconds. Negative 45 over 5 is negative 9. And we see this third section here, this third segment. It goes from negative 15 to positive 30. It goes up 45, and that also takes from 10 to 15 seconds. That also takes 5 seconds. So that would be positive 9. Now that I know what velocities I actually need to graph, I'm going to go ahead and put them on here. I need a positive 9, and I need a negative 9. And I would show these are at the same speed, just in opposite directions, and I'd show that by trying to put them the same distance from 0. And I'm going to scale my time axis the same way it's scaled in the position time graph, because this is the exact same event. It's a different graph for the exact same event. For the first 5 seconds, it was going 0. For the next 5 seconds, it was negative 9. That should be a little more horizontal. And for the last 5 seconds, it was going positive 9. And remember, these little dotted lines are just to help you track where your lines are, where one starts and the other ends in a velocity time graph. So that's what number 3 should look like. And here's the last one I'm going to do. We have this first section of line in 5 seconds. It goes from positive 30 to negative 15. So it goes down 45. In 5 seconds, this has a slope of negative 9. In the next 5 seconds, it has a 0 slope. And in the last 5 seconds, from 10 to 15, it goes up 15 in 5 seconds, so it has a slope of positive 3. Does this make sense? Yes, this should be negative, and it is steeper than this last one here that should be positive. So just take a look and make sure what you're calculating makes sense. It's easy to make silly arithmetic mistakes, and I don't want that to cost you. So just make sure. This should be negative and it's steeper, so it should be a bigger magnitude, and it is. So here we have to graph a velocity of 3, and here's 3, 6, here's negative 9. I have to graph that too, and I'm going to scale the horizontal or the time axis in the same way as it is for the position time graph, because this is a corresponding graph. These two graphs show the exact same motion. They're just different ways to present the same motion. So first 5 seconds, it's at negative 9 at a constant velocity of negative 9, whatever, meters per second, maybe, it doesn't say. For the next 5 seconds, it's at rest with a 0 velocity. That's the only way we can show something's at rest. And for the final 5 seconds, it is going at a velocity of positive 3. And so that is how I would show that.